Welcome to my channel. Today we are going to solve a nice geometry problem. The given information is they are given a quarter circle. Inside the quarter circle we have a semicircle and small circle. The quarter circle radius is 16 units. We need to find a radius of the small circle and area of the small circle. According to the given information, what we can do to solve for radius and area. First we will discuss about that. It is a semicircle. This is the center of the semicircle. This length is, this is the diameter of the semicircle, but it is radius of the quarter circle, right? So we know that radius of the quarter circle is 16 units. So that means this total distance is 16 units. This diameter, then this distance is a radius of the semicircle, isn't it? If diameter is 16, then radius is half of the diameter. That means radius of the semicircle is 8 units. This is the center of the quarter circle, so name it as O. This is the center of the semicircle, name it as B. And this is the center of the small circle, name it as B. And observe here, the semicircle and a circle are touching at one point. This point is known as point of tangency, isn't it? So this point, name it as C. And observe the small circle and quarter circle. So this is the point of tangency. Just name it as D. If you draw a line from center of the semicircle to here, it is nothing but radius of the semicircle, isn't it? And we know that radius of the semicircle that is 8 units, right? So just write 8. And if you draw from center of the small circle to this point, it is nothing but radius of the small circle. So we don't know that radius of the small circle, just assume it as capital R. Then AB length is 8 plus R. Now, draw a line from the center of the quarter circle, passes through center of the small circle and to the point of tangency, the point D. If this OD line is nothing but radius of the quarter circle, isn't it? And we know that radius of the quarter circle is 16 units. So that means OD length is 16 units. BD is nothing but radius of the small circle. So BD length is R units. So OD length, we can write this as OP plus BD, isn't it? From here we can find OB length. OD minus BD. OD is nothing but 16 and BD is nothing but radius of small circle. So OB is length is 16 minus R. From the given information we found this. OB equal to 16 minus R, AB equal to 8 plus R. Suppose if we draw a line from center of the small circle to here, name it this point as E. So we formed a two triangles. Now we are going to find AE length, and we know that OA length is 8 units. If we draw a line from small circle to here, it is nothing but radius. So if after drawing from B to E, we formed a rectangle, right? And we know that in rectangle opposite sides are equal. This is the radius. OE is nothing but radius. And we know that OA length is 8 units. OA length is 8 units. OE length is R units. From that we are going to find AE length. OA, we can write this as OE plus AE, right? And OE minus OE is nothing but AE, right? So OA is 8 units, just write 8. And OE is R. So AE is nothing but 8 minus R. So we formed a two triangles. One is BEA. Another triangle is OEB. So and we know that AB length is 8 plus R. 8 plus R. OB length which is 16 minus R. So this distance is 8 minus R. From the triangle BEA, we are going to find EB length. So it is a right angle triangle. So we can use the Pythagorean theorem here. This is the angle and angle opposite side AE. AE is 8 minus R. So what is the formula? Opposite square that is 8 minus r whole square plus adjacent side square, that is be whole square, that is equal to hypotenuse square, which is 8 plus r whole square. Be whole square, that is equal to 8 plus r whole square minus 8 minus r whole square. Now it is in the form of a plus b whole square minus a minus b whole square. We know that the formula is 4ab, isn't it? We know this. So according to that formula, we are going to substitute a and b. 4 times a is nothing but 8. B is nothing but r. That means 32 r. Be whole square, the distance is 32 r. If you take square root on both sides, then BE length is square root of 32 r. 32 we can write it as 16 times 2, so that we can write it as 4 root 2r, isn't it? Now let's take another triangle, which is OEB triangle. This is the angle. Opposite side is BE. Just now we found BE length is 4 root 2r and OE the length is r. OB the length is 16 minus r. OB length is 16 minus r. This is 16 minus r. This is the adjacent side. This is the opposite side. This is the hypotenuse. This is the right angle triangle. So we can use Pythagoras formula here of hypotenuse square equal to, that is 16 minus r whole square equal to opposite square, which is 4 root 2r whole square plus adjacent side square, which is OE. OE is nothing but r, that is r square. If you expand this, this is in the form of a minus b whole square. So that is a square, which is 16 square, that is 256 plus r square minus 2ab, that means 16 times 2, which is 32r, that is equal to 4 root 2r whole square, which gives 16 times 2r plus r square. If you send this right hand side to left hand side, then it becomes minus 16 times 2r, and even this also minus r square, that is equal to 0. Here plus r square minus r square gets cancelled. So what you left? 256 minus 32r minus 32r, which gives minus 64r, that is equal to 0. So 64r, that is equal to 256. Then r, the radius is equal to 256 divided by 64. So which gives 4. 64. 4 times is 256. That is radius is 4 units. So still you need to find the area of the small triangle. So what is the formula for the circle? Pi r square, isn't it? So pi r square is nothing but 4 square, which is 16. So the area of the small circle is 16 pi square units. That's it. I hope you like this content. If you like this content, please subscribe to my channel. Thank you for watching.